This is section 10.4. We're going to be adding, subtracting, and dividing radical expressions in 10.4. This is part 1. So today we're just going to be adding and subtracting, which is our objective, add and subtract radical expressions. In part 2 we'll do the dividing. And when you add radical expressions, it's like adding variables. You have to have like terms when you add variables. When you have radicals, you have to add like radicals. It's the same principle. So let's look at example 1 and see if we can't do that. You can see in example 1 we got square root of 2 on each of these. That's like radicals. They got to have the same root and the same number underneath the radical sign. So we can add these, and you add them similar that you do variables. If I add 2x plus 3x, I get 5x. The x doesn't change. The power doesn't change. The only thing that changes is the number in front. So if I'm going to add 7 square root of 2 plus 8 square root of 2, the only thing that's going to change is the number in front. That's going to be 15 times the square root of 2. That's our answer. You add the two numbers in front of the radicals, and the square root stays the same. Let's look at B. We've got cube roots. Works the same with cube roots like it does square roots. You're going to add or subtract the numbers in front as long as you have the same, or if you have like radicals. And we do. They're all cube root of 5, so we can add B cube root of 5. This one's considered a 1 cube root of 5, so we can do 1 cube root of 5 minus 4x cube root of 5 and plus 8 cube root of 5. We can add the 1 and the 8 and get 9, and then from that we can subtract 4x. And if you remember, we are multiplying that times the cube root of 5, so we have to multiply that whole thing because we added the 1 and the 8. So to multiply the whole thing, we need parentheses times the cube root of 5. So 9 minus 4x in parentheses times the cube root of 5. Let's look at C. You've got 8 sixth root of 5x minus 5 sixth root of 5x plus 4 cube root of 3, or cube root of 5x. You cannot add the cube root to the sixth root, but we can subtract the two sixth roots because those are like. The cube root is not like the sixth root. So if we do that, we got 8 minus 5, that's 3 times the sixth root of 5x, and this other plus 4 cube root of 5x just gets added on, plus 4 cube root of 5x, and that's simplified. And that's all there is to it for adding and subtracting. Stop, pause here, do your checkpoint, come back, I'll give you the answer. Alright, so checkpoint 1A is 10 times the square root of 13. B is 21 minus 6x. 21 minus 6x times the cube root of 7. And C is 5 times the fourth root of 3x plus 2 times the cube root of 3x. Okay, that's your checkpoint. Let's look at example 2. We're going to have to do a little simplifying in example 2, and we're going to need lots of room for this. We're going to have to do some simplifying before we can add them because they have to be like radicals, remember? And so we got the square root, or 7 times the square root of 18 plus 5 times the square root of 8. We're going to reduce each radical, and when we do that, we're going to end up, in order to add them, they have to be alike. So they're going to end up with a like radical at the end in order to finish the problem. So 7 just stays a 7. It gets multiplied by whatever we're going to have to split square root of 18 up to. We need two numbers that multiply to 18, and one of which has to be a perfect square number. Well, 9 is a perfect square number, so 9 times 2 makes 18. So we're going to say 7 times the square root of 9 times the square root of 2 plus 5 times, and then we're going to have to do the same thing with 8. The perfect square number that goes into 8 is 4, so we're going to say 5 times the square root of 4 times the square root of 2. And if we take the square root of 9, we get 3, so 7 times 3 times the square root of 2. And 5 times the square root of 4 is 2 times the square root of 2, which makes 21 square root of 2 plus 10 square root of 2. And 21 plus 10 is 31 square root of 2. So we can finally add it in the end. That's our answer. Let's look at B. You've got 27x and 12x that we're going to have to simplify under the square root. So if we start off with 4, 27 is 9 times 3, and the square root of 9 we can take. So it would be 24 times the square root of 9 times the square root of 3, and I'm going to put the x with the 3 because I know that I cannot take the square root of x. It can't be divided by 2 without making a fraction. So that's going to be under the radical by itself anyways, or that's going to be stay under the radical in the end, and so is 3. I can't take the square root of 3, so I'm going to keep that under the radical in the end. So you got 4 square root of 9 times the square root of 3x minus, and in order to subtract these, we're going to have a square root of 3x in the end. 12 breaks down into 4 times 3, so it would be minus 8 times the square root of 4 times the square root of 3, and again, I'm going to put that x underneath there. The square root of 9 is 3, so we got 4 times 3 times the square root of 3x minus 8 times 2 times the square root of 3x. This is a times, by the way, not a minus. So 4 times 3 is 12, square root of 3x. This is a minus, and then 8 times 2 is 16, square root of 3x. 12 minus 16 ends up with a negative 4, square root of 3x. Let's look at C. We've got 7 square root of 3 minus 2 square roots of 5. We can't break down square root of 3. There's no perfect square number that goes into it, besides 1, but 1 doesn't really do anything for us. Same thing with 5. There's no perfect square number that goes into 5 evenly. So this one can't be simple, or can't be done. Can't be done, so we would just say it is simplified. Try your checkpoints here. Pause the tape. When you come back, I'll give you the answers. They're on the next page. Okay, so checkpoint 2. The answers are 21 square root of 5 for A. B is negative 12 square root of 3x. And C is can't be done, so it is just simplified. Let's look what happens with higher powers, like example 3. So cube roots, stuff like that. Let's move this up a bit. We got to combine, it says simplify by combining like radical terms. You got 2 cube root of 16 minus 4 cube root of 54. Works the same with square roots. We got to have a like radical, so it's got to be a like cube root in order to subtract. I can break cube root of 16 down into 8 times 2, and the cube root of 8 I know is 2. So we're going to take 2 times the cube root of 8 times the cube root of 2. Minus 4, and 54 works out to 27 times 2. And the cube root of 27 is 3, so that will work. So we got the cube root of 27 times the cube root of 2. Alright, so if I take the cube roots of whatever I can take the cube root of, so I got 2 times the cube root of 8 is 2. times the cube root of 2 minus 4 times the cube root of 27 is 3 times the cube root of 2. If I do my multiplication, I got 4 times the cube root of 2 minus 12 times the cube root of 2. And 4 minus 12 is negative 8 cube root of 2. That's the answer for A. Let's look at B. You got 5 cube root of xy squared plus cube root of 8x to the 4th y to the 5th. I can't take the cube root of x because it's got to be 3 or bigger, and I can't take cube root of y squared because that's got to be 3 or bigger for the power. So that's just going to stay like it is, which means when I take the cube root of this right one, I better end up with the cube root of xy squared in order to add these two. So let's see what we can do with the part on the right. So we're going to start first of all with 5xy squared. We're not going to do anything with that. Plus, we're going to take the cube root of 8. And we're going to split everything up. Cube root of 4, or cube root of x to the 4th, I should say, I can split up into the cube root of x cubed times the cube root of x. Okay, x cubed times x is still 4, x to the 4th. So that didn't really change the problem there. And times, oops, that doesn't look like a times. Times the cube root of y to the 3rd times the cube root of y. And y to the 3rd, y squared. Because y to the 3rd times y squared is still y to the 5th. All right, so the first thing didn't change. Cube root of xy squared plus the cube root of 8 is 2. The cube root of x cubed is x, and we got a cube root of x. The cube root of y cubed is y, and we got a cube root of y squared. So we got 5 cube root of x, y squared still in the first term. The second term becomes anything that we took the cube root of goes out front, just like we did in last section. 2xy, and we're going to have a cube root, one big cube root for the xy squared, and we did end up with a like radical. So now we can add them. 5 plus 2xy, and we're going to be multiplying that whole thing by the cube root of xy squared. That's the answer for part B, checkpoint B. Example 3B. Try your checkpoint 3, and when you come back, pause here, and when you come back, and I'll give you the answer. All right, so the answer to checkpoint 3, A is negative 9 cube root of 3. And B is 5 plus 3xy cube root of x squared y. That's all for part 1 of 10.4. I will see you in class.